What's up, YouTube? Okay, Mr. King coming to you live from the studio today. Here's what we got. Today we're going to be going over the Doppler effect. Okay? So you're going to learn, why does the pitch drop if I run away? But I also want to give you the do now questions to get us started. Just a little bit review. Please answer these questions on the worksheet that the sub gives you. Pause the video now and answer. And you should have gotten that the distance from where the baseball player is to where you are in the stands is the speed times time. And you should have gotten 514.5 meters. And if a person is running away from you, then the pitch will drop. So you should have seen that during our lab. And you're going to learn why we see that effect today based on the formula. Okay? And just some review. So while you're doing this, you should be filling out the worksheet right here. So, a little review. What is the formula for speed? Remember, speed is distance divided by time, but for a wave, it's also the wavelength of the wave, the distance, and then the frequency is how many there are per second. So you multiply the wavelength times the frequency to get the speed of the wave. Okay? Moving on. Here is the Doppler effect formula. It is very weird because it has a plus and a minus on the top, and then a minus and then plus on the bottom. You've never seen anything like that in physics, or maybe even in math. So we're going to talk about it, but first, on your worksheet, could you fill out the F0, that's the frequency that you observe, O is for observer, Fs is for the source, whatever's making the sound, V, in this case we're going to use the velocity for the speed of sound, 343, V0 or VO is the observer's velocity, and then down here is the same velocity of the sound, 343, and here's the velocity of the source, whatever's making the sound. And then in your worksheet, I want you to remember this. Top is toward, and then bottom is beway. Okay? I know that sounds weird, but I couldn't think of a word that meant like away from you that started with a B. So I'm just going to say the bottom is beway. So if someone's running toward you, use the top ones. Okay? So we're going to practice. But that's how the plus and minus work. Please pause the video now and make sure you got what each one represents. And that toward, use the top ones if it's toward you, and the bottom ones for away from you. Okay. Here's my example problem. If Mr. Keen is running at you at 5 meters per second, and I'm playing a frequency on my phone with 10,000 hertz. If you were just standing there, what is the new frequency that you hear? Or your observed frequency? And then my follow-up question for you, what is the frequency if you run toward me at 5 meters per second too? So we will both be running in the part B. Okay, so I'm going to have you pause the video now. Can you try and plug in what you know? Plug in what you know. We know that the frequency of the source, I told you, it's 10,000. So you put 10,000 here. 10,000, 10K. Okay. And we know that the velocity is 343. And we know that I told you you're standing there. So that means the observer is not moving. So that one's 0. And then I'm the source, I'm playing the sound, and I'm going 5. Okay? So over here, the observed is going to be 10,000 or 10K times, and then 343 plus 0 is 343 divided by, and then 343 minus 5 is 338. Okay? If you put this in your calculator, you should get a frequency that is slightly higher than 10,000, which makes sense. And I forgot to mention that since I'm running toward you, we're going to use the top. So it will be 343 plus 0, and then 343 minus 5. So that's how I got 343 and 338, because I used the top ones. Okay? So that should get you a number that's slightly above 10,000. And then for part B, I'm going to have you pause the video now and do it by yourself. Pause the video and do it by yourself. Okay? Once you answered A and B, can you, once you finish, here are the answers. You should have gotten 10,147, 10,296. This makes sense because when someone is approaching you, someone's higher. The pitch is higher. So if two people are going toward you, it'll be even higher than that.
Yeah.
So based on the video, you should be able to answer part Doppler effect notes. And then the homework, you should be able to do all by yourself. Okay? Great. Thanks so much. Have a great rest of your night.